Bonjour, welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate. If you'd like to participate live today, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday, 10 until 11 in the morning, and we are in our 9th and final week of our course. You definitely should be submitting work to be marked at this point, though a reminder that if you are registered in the radio Zoom class, that you can be automatically transferred over to the IL course, and then you have until mid-June to submit all your work. Just reach out to us and let us know that that's what you'd like to do. So the support questions you should know are practice problems that are not for marking. You decide which ones and how many to do. If you're understanding concept, it's totally okay to skip questions. You do what is best for you with your time. The answers are in the back of your booklet, so I strongly encourage you to do some of the questions and then check your work to make sure you're on the right track. The key questions, the ones with a little key icon, are the marked questions. So these you need to do all of them. You need to show your work, your steps, and your thinking. This way, I know what it is that you understand, and if you're struggling with something, I have more information so that I can actually help you if you need some support. So how do you submit your work for marking? There's 3 methods. The first is to send your work and scan it. Scan your work and send it electronically. If you have a device, you can use that to scan. The Apple devices have a Notes app, and the Android devices have a Google Drive app. These are free apps that generally come with these devices that are pretty straightforward to use. However, if you do need some support, on my YouTube channel, there are tech tutorials that will walk you through step-by-step how to use these different apps and scan your work. Then you can send it to me through email to studentwork@nnec.on.ca and CC it to me, Bronwyn Slate, at nnec.on.ca. Or you can also send it to me through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off into Lookout. We have an outdoor mailbox at our location, 74 Front Street. We are the bright red building next to the post office and have a small white mailbox next to our side entrance. So you can just put your work in there at any time, and I will get it back to you as soon as I can. The third method is to hand your work into your DEC. Then your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work. Just give us a heads up that it's coming, because sometimes things get lost in the shuffle, so we want to make sure we don't lose your work. If you want to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. So all of our radio Zoom classes are recorded, and I upload them to YouTube shortly after broadcasting, and I put them in a playlist called MBF3C. So they're really easy to find there. There's also short videos that explain common errors, confusing concepts if you're struggling with something. So that's a good place to check out to make sure you have all the tools that you need. Math is a really visual subject, so I strongly encourage you to access the YouTube videos. This is really going to set you up for most success. If you can't join me live through Zoom, you don't have to talk to me. You can just watch. Or if you can't watch the YouTube videos for some reason, then let me know, and I'm happy to send you a copy of the videos so you still get the full experience. So if you have any questions or concerns, please reach out and connect with me. I'm here to support you however I can. You can email me at bronwyn.slate@nnec.on.ca. Connect with me through Facebook, where my name is B. Slate Wahsa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11, so that is not a good time to try to get a hold of me. Today, we are continuing with our review on Unit 2. Our previous session, we reviewed Unit 1, which was lessons 1 through 5. So now we will be looking at lessons 6 through 10. But first, let's activate your brain with some mental math. Hopefully by now you know that I'm not a supporter of Mad Math Minutes, and I don't believe they set people up for success or really help anybody. They just cause stress and anxiety. So instead, we work on building strategies that use our own comfort and confidence with numbers. Our question today is 371, take away 169, and we're using the strategy of constant difference. So I like to visualize this on a number line because the idea with this subtraction is that the difference between the two numbers is the same. So we're starting at 371, and we want to figure out what's the difference between 371 and 169. We're looking at what this distance is. That's what we're wondering, which is another way to think about subtraction. So what you can do is you can shift your whole problem just however you want, up or down, and keep that distance the same if we shift the same amount. So I'm going to shift 169 to 170 and 371 to 372. I just shifted it up by 1 for each thing. And so my distance is still the same. This is still the same because I shifted both numbers up once. And so now I can see that this is just 202. This distance is 202. And so if the distance is 202 between my red line, when I shifted, it's going to still be 202 for my black line when it wasn't shifted. And that is how constant difference can be really useful. All right, so before we dive into our review, I just want to talk about your final assessment so you know what to expect. So with your final assessment, it is not an exam, it's a culminating assignment. So instead of you having to go into a room and sit for 2 hours and not have access to any of your resources and just do it in that stressful situation, culminating means that you have it for a period of time. So it still covers all of your lessons. You still have to know everything. It's not just that it covers a smaller amount, it covers everything, but it's open book. So you have access to your assignments, to the YouTube videos, to your IL booklet, to Desmos and virtual manipulatives, any of the resources that we used online. You can talk to other people. You can ask me questions to clarify things. I can't check your work, but I can make sure that you understand what the question's asking. It's not timed, so it's not like you only have 2 hours to do it, like I said, but it does have a deadline. So when I give it to you, we'll discuss that, and depending on your life, what's going on, if 2 or 3 weeks, depending on what's going on, if that makes sense to you, so that we know when I'm expecting it back. The structure is likely to be unfamiliar. It is not the same as your IL booklets. It is not just straight questions that you look up and then follow the steps. It's different. You have to be a bit more creative, and it is going to be time consuming. So don't just think that don't leave it to the last minute. It is going to take some time to do, but you can still do it. Use the skills that you've learned. All right, so let's look at lesson 6. Again, we're reviewing unit 2 today. So lesson 6 is simple interest and linear growth. So simple interest, remember, is both an arithmetic sequence and linear growth. They all represent the same thing. It's when the pattern increases or decreases at a constant rate. So we're adding the same amount each time. Our formula is I equals PRT. So I equals P times R times T, where I is your interest earned, your P is your principal amount, your R is your interest rate, which is a percent as a decimal, right? That's going to be given to you as a percent, but we have to use it as decimal. and your time, which has to be in years, which is T. So when T is in years, we have to convert it. So we have 12 months is equal to 1 year. So 9 months is going to be converted into 9 divided by 12 is 0.75 years. 52 weeks is 1 year. So if it says 60 weeks, then you do 60 divided by 52, which is 1.15 years. If it's in days, so you have 365 days a year. So if you have 700 days, then you do 700 divided by 365 and you get 1.9 years. So remember, you have to convert it into years. Also, if you are looking for the final amount, you have to do your principal plus your interest. That first formula just calculates how much interest you make. All right, so let's do some practice questions to make sure we actually understand what that means. So number 1, determine the interest earned on a principal of $800 at 4% for 3 years. So I like to list my variables. So P equals 800, R equals 4%, which is 0.04. This is really useful for me. If you make a mistake, then I can see where maybe that came from. And T is equal to 3 because it's 3 years. So the interest is equal to principal times rate times time. So 800 times 0.04 times 3. I put this all in my calculator in one go. And we get $96. So that is what the amount of interest that we've earned on that investment. Number 2, determine the principal of if the interest earned was $15.31 at 5.25% for 7 months. So again, this is really important to list your variables because if we look, we see determine the principal. We don't know it. That's what we're trying to figure out. So our interest earned is equal to $15.31. Our rate is 5.25%, which is equal to 0.0525. And our time is equal to 7 months, which is 7 divided by 12. So we're still going to use our same formula, I equals PRT. But this time, when we're substituting in, well, we know what I is. So 1531 is equal to, we don't know P, so we're going to leave that. Then R is 0.0525. And T is equal to 7 divided by 12. So then you can do those calculations, or you can isolate for P first. I like to do everything in my calculator once. But again, you don't have to do it my way. This might be confusing for you, and that's fine. But we're solving for P, so we have to isolate for P. So equals $499.92. So the principal is equal to $499.92. That's how much was invested. So you can figure that out, both figuring out your interest, or you could figure out your principal or your rate or your time, depending on rearranging and isolating for the right variable. All right, lesson 7. We're looking at compound interest and exponential growth. So compound interest and exponential growth, remember that what this means is that compound interest, you grow exponentially because your pattern increases or decreases by a constant ratio. You're multiplying by the same thing each time. The formula is A equals P times 1 plus R divided by N to the exponent NT. You do not have to have this memorized. You can look it up. That is fine. But A is equal to your final amount. P is your principal still. R is your interest rate as a decimal. T is your time in years, and then the different piece, other than the formula being different, but the different variable here is N, which is your number of compounding periods. To find your interest, you need to do your final amount, which you calculated, take away your principal to find that interest. All right, so practice question number 5, determine the amount on a principal of 1,200 at 3% compounded quarterly for 6 years. Again, listing your variables helps you be organized. So P equals 1,200, R equals 3%, which is 0.03. N is compounded quarterly, so that's 4. There's 4 times per year. And T is equal to 6 because it's 6 years. You don't have to put your variables in the same order that I do it. That's fine. You can do what makes sense to you. Then you have your formula. Again, you do not have to have it memorized. You can look it up. You need to know how to use it, not have it memorized. So A is equal to P, which is 1,200 times 1 plus R, which is 0.03, divided by N, which is 4, to the exponent NT, which is 4 times 6. Again, you can do this in steps on your calculator, or like I like to do it, you can just do it all in one step. You need to make sure either way that order of operations is happening accurately, because calculators are going to do what they think you want them to do. They aren't necessarily going to do what they want you to do. You have to be paying attention. And you need to make sure that you're doing order of operations correctly if you don't do it all in your calculator one step. So that's $1,435.69.6, so 70 cents. So that is the amount the total amount. So then part B, how much interest was earned? Well, interest, remember, is the amount to take away the principal. So we have $1,435.70. Take away the principal of $1,200. So $235.70 was the interest that is earned in this situation. All right, lesson number 8, the compound interest formula. So we're still talking about compound interest, but we're looking at it a little bit more deeper because it's a little bit more complicated to solve for the various variables. So dissecting your compound interest formula, a problem, you need to make sure that the word compound is in the question. If it doesn't say compound, then we don't know that it's a compounding interest question. So it has to say compound somewhere. You must identify what information is given and what you're being asked to find, because it might not always be the same. So we're finding the principal, your P. You need to rearrange your formula using algebra to isolate for P. Very similar to what we did for isolating for P in their simple interest question. There's nothing too tricky there. If you're finding your interest rate, you need to use the nth root to isolate for R. So because your R is going to have an exponent, you need to use your nth root. So whatever the exponent is, that root, in order to isolate for your R. And if you're finding your time length, your T, you need to use a guess and check to force your bases to be the same. And then the exponents can be set as equal in order to isolate for T. So again, this is tricky. If you need to go back to the lesson 8 to check that out a little bit more, totally go for it. We'll continue to review this. We'll do a little bit of practice, but if you need more, go back to lesson 8 and check that out again, because these ones are a little bit tricky. Mathematically, there is a way to find out your time length, your T, without guess and check, but we haven't learned how to do it. It's not something that we need to learn in this level. So that's why we're just using the guess and check system. All right, so number 7, our principal of $2,000 amounts to $24,400 when compounded annually for 8 years. Determine the annual interest rate as a percent to 1 decimal place. So again, it says compound. So we know this is a compound interest question. That's our first thing. And then our second thing, we're going to use our variables. We're going to list our variables to figure out what we know and what we don't know. So the principal is $20,000. The amount, so how much after invested, is $24,400. That's our A. Our compounded annually, so our N compounded annually is 1, and our T is 8 because it's 8 years, and R is what we're trying to figure out. So we know what variables we know what we don't know. So now we're going to use our formula. It's still the same formula, right? We're just solving for something other than A. I still like to write out my full formula to make sure that I'm starting off with the correct place. Then if I see you've made a mistake there, it gives you more information opposed to if you don't write out your formula. It also helps you remember it the more times you write it out. R, we don't know, so we're leaving R as the variable. And then we're going to simplify this as much as we can. So, oh, I forgot to put in what my A was. So 24,400 divided by 20,000. That's what we want to do. So then 1 plus R, we can't simplify that anymore to the exponent 8. So then we're going to do 24,400 divided by 20,000 is equal to 1.22 is equal to 1 plus R to the exponent 8. So then in order to do the inverse of the exponent 8, we're going to do the 8th root of both sides. So this is saying what number times itself 8 times equals 100 equals 1.22. So that is this nth root button. And then we put in 8 because that's how many we want the 8th root, and then 1.22. So that equals to 1.0252, which is equal to 1 plus R. So then we subtract 1 from both sides to get R by itself. And then the question says it wants it to a percentage as a so we're going to convert this decimal to a percentage. So we're going to times it by 100. So we get 2.5% is equal to R. And that's how you do the nth root. Not too tricky, just a button on your calculator. So number 8, how long was a principal of $500 invested at 4% compounded semi-annually if the amount was $746? So again, it says compounded. So we know we are doing a compound question. We're going to do our variables. P is 500. A is 746. R is 4%. So 0.04. N is 2 because semi-annually is 2. And T is our question mark. That's what we're trying to find out. How long is what it tells us. So again, using our formula. And then we put in what we know. So A is 746 is equal to 500 times 1 plus our rate is 0.04 divided by 2, all to the exponent 2t, because t we don't know, n is 2. So we're going to try to isolate, we're going to simplify as much as we can. So 746 divided by 500, we can simplify that. And then 1 plus 0.04 divided by 2 is going to be 1.02, all to the exponent 2t. So then we do our division. 746 divided by 500 is equal to 1.492. So remember, we're guessing and checking. To do this, we're trying to figure out a number that gets us as close to a base of 1.02. That's what we want. So we have to figure out what exponent on, sorry, my brain is just blanking. We do 1.492 to the exponent what is going to get us close to 1 point. No, I have that backwards. That's what I thought. Okay. We're trying to figure out 1.02 to the exponent what gets us close to 1.492. So let's do the exponent 5. And we get 1.104. So close, but not so close. So we do 1.02 to the exponent. Let's do the exponent 10. And we get 1.218. Getting closer, but we're looking for 1.492. So we do 1.02 to the exponent. Let's do 20. And we get 1.485. And we're getting closer. 1.02 to the exponent. Let's do 25. And we get 1.64. Okay, we're too big. So 1.02 to the exponent 21. We get 1.51. So that's also pretty big. That's bigger than we want it to be. So we can do 1.02 to the exponent. Let's do 20.5. And that gets us to 1.5. So again, we can continue to do this, or we can just go with 20. So we can try to get it a little bit more precise. But so 20.2 gets us at 1.492. So then what we say is we say 1.02 to the exponent 20.2 is equal to 1.02 approximately to the exponent 2t. So now that our bases are the same, that means that 20.2 is equal to 2t. And then we can now solve for t, which is equal to 10.1. So it took 10.1 years in order for the principal to go from $500 to $746. So as you can see, you don't have to write down all your guess checks. You can if you want to. If that helps you, great. If you want to communicate that to me, that's fine. But you can also just use a calculator like I did in order to figure out what this for this guess and step check. Guess and check step. There we go. All right, lesson number 9. This is loans and RSPs. You need to understand compounding interest. Understanding the previous formulas is that being comfortable with is going to help you go with these ones because these ones are more complicated. So with loans, this is when you borrow money that is paid back through equal payments over a set period of time, including the interest. So the payments are calculated according to how much you want to borrow. So use the formula R equals, so R being your payment, equals PV times I divided by 1 minus 1 plus I to the exponent negative n. Or how much you can borrow is calculated according to the payment that you can afford. So PV equals R times 1 minus 1 plus I to the exponent negative n, all divided by I. Again, you do not need to have these memorized. I don't have these ones memorized. These ones I have to look up to make sure I have the right one for the right situation because they're very, very similar. Loans are used for, these formulas are used for just straight up loans, but also for RSP annuities and car payments. Remember, your PV is the amount that must be invested, the amount that it's worth, you're financing now, that's your present value is what we call it. Your A is the amount of the annuity is worth. Your R is your regular payment. Your I is your interest rate, which is expressed as a decimal, just the same, but it's per compounding year or compounding period. So this is a little bit different. And your N is your number of payments made in the total years. So that's also, you need to know your total years and as well as your compounding period. So RSPs are a saving plan that are made for people who earn income, and you make regular contributions into the savings plan. And then you can calculate either your goal amount, how much you want to have, by doing A equals R times 1 plus I to the exponent N divided by, minus 1 divided by I. Or you can figure out based on how much of an affordable payment is, you can figure out, like if you know how much money you want, you can figure out if you can afford that payment. So R equals A times I divided by 1 plus I to the exponent N minus 1. Again, these things you need to make sure you're doing your order of operations correctly. You can't just cancel off those ones. They're not. You have to do your order of operations. You have to do inside your brackets and your exponent first before doing that subtraction. So an RSP pays a regular payment to you once you retire. You can have it paid out as a lump sum, or you can set it up to be an annuity, which pays you a regular amount while the remaining amount still continues to earn you interest. If you can invest early, then you get more interest in the long run because it is compounded. However, investing when you can invest is better than never investing because you're like, I didn't invest early, so there's no point in doing it now. If you can invest, you're going to earn some interest. So this part is super, super important, and it can be confusing because how do you know which equation to use in which situation? So when we go through these, I told you to screenshot them when we did this previously in lesson 9, but I'm going to do it again and tell you to screenshot them or save this to help you figure out when to use which formula because it is confusing. So if your question includes one total amount invested or borrowed at simple interest, you use I equals PRT. That's your simple interest. If it says simple interest, you use simple interest. And that's one amount. You're not making payments. You're just doing one amount at the beginning. If you're doing one total amount that's invested or borrowed with compound interest, you use A equals P times 1 plus R divided by N to the exponent NT. Again, one total amount, but this time it's compound interest. Then this is when things start to get tricky. So if you have a loan or an RSP with payments, it might say compounded, it might not. And you're looking for the total amount. So you know how much your payments are going to be, how much you're going to be doing, how often you're going to be doing it. You use the PV equals R times 1 minus 1 plus I to the exponent negative N divided by I formula. If you have your loan or your RSP with payments, again, might say compound, it might not, and you're looking for the payment amount, so you know that you're paying off a loan or you know that the RSP is paying you, and you're looking for how much that payment's going to be, you do R equals PV times I divided by 1 minus 1 plus I to the exponent negative N. Again, this is why we save this sheet, because there's lots of formulas. Then, if you're contributing to an RSP and you're looking for the final amount, so you know how much payment you're making and how often you're making that payment, then you can figure out how much you're going to have in total after a certain period of time by A equals R times 1 plus I to the exponent N minus 1 divided by I. Or if you're contributing to an RSP and you're looking for the payment amount, so you know you want to have $1 million and how much you're gonna have to pay each month to get that amount, you do R equals A times I divided by 1 plus I to the exponent n minus 1. Again, screenshot this slide. This really helps to keep yourself organized. I needed to do this screen for myself in order to figure out which formula to use in which moment, because it is confusing. Okay, so then let's look at the question. Number 9, a monthly payment of $250 is deposited into an RSP for 25 years and is compounded monthly at 7.75% per annum. What will the final value of the RSP? Okay, so we know we have a monthly payment of, so we know our monthly payment. We know that we're trying to find out the final value of our RSP. So we're making contributions to our RSP. So we know that we're going to be we're contributing to an RSP and we're looking for the final amount. So we're using this formula. So the A equals R times 1 plus I to the exponent n minus 1 divided by I. Let's see if I can remember that long enough to write it down. Usually I help myself out. Today I didn't. So that's what I think it is. I'm gonna go back and check it. Yep, that is correct. Okay, so I know my monthly payment is R is equal to $250. My time length is 25 years and it's compounded monthly. So my N is going to be 25 times 12. And my I is equal to 7.75% compounded monthly. So that's 0.0775 divided by 12. So then I put those into my formula. And it is not particularly pretty to write down because there's lots of little parts. This is partially why I like to do it on my Desmos calculator all at once, because then I can see. Desmos is great and you can see the whole thing. On your phone, I think if you use it, it's a little bit harder to see, but I'm not sure. I just don't do it on my phone all that often. I do it on my computer all the time. So I can make sure that I have all of my brackets in the right places. Oops. Then I want -1. And then I want all of that divided by 0.0775 divided by 12. So that means that my final amount, is equal to $228,320.03. So that's how much if you contribute $250 every month for 25 years, then you'll have that much money after that 25 years. Then you can reinvest your RSP at a rate of 6.77% in an annuity that pays monthly payments for 20 years. What payments will you receive? So again, we're reinvesting. So that means that we're getting paid now, and we're looking for our payments. So R equals PV times times I divided by 1 take away 1 plus I to the exponent negative n? I'm guessing. I don't actually know. Again, I usually help myself out. This time I didn't. Okay, so we know that we are getting an RSP payments and we're looking for the payment amount. So that is this one here. So PV times I divided by 1 minus 1 plus I to the exponent negative n. I think that's what I did. Nice. Again, I don't expect you to memorize it because I can barely memorize it. So our PV, our present value, that's how much money we have to start with, is what we calculated in the previous question. So that's the $228,320.03. Our I interest rate this time is 6.77% compounded. It doesn't say compounded, but it's monthly because we're getting monthly payments. So 0.0677 divided by 12. And our N is 20 because we want 20 payments, monthly payments. So 20 times 12. So then we put that all into our formula, $228,320.03 times 0.0677 divided by 12 divided by 1, take away 1 plus 0.07677, sorry, divided by 12 to the exponent negative 20 times 12. These are hard. They are lots of numbers and they're tricky. So it's okay if you find them tricky because they are. By 12. Oops, that's not 12. And then I want that. I'm putting that all in brackets because I want it all to be divided by what I'm putting on the bottom. 1 minus 1 plus. So it does take a little bit of practice using whatever calculator you're using to make sure you get all of the order of operations properly done with these tricky steps. So your monthly payment is going to be $1,738.78. And that's what your RSP is going to give you every month for 20 years. Again, if you need more practice, go back and check out lesson 9. All right, and then finally, lesson 10, which is buying new and used vehicles and vehicle costs. So remember, buying a new vehicle, if you're calculating the monthly payment, is the formula that we've just been talking about. So R equals PV times I divided by 1 minus 1 plus I to exponent negative n. And we also learned how to complete a deal review, which tells you all the different parts that you need to pay for. If you're buying a used vehicle, then we talked about how to calculate the resale value, which uses the depreciation rate. So value is equal to principal, or sorry, the price times 1 minus R to the exponent n. So where V is your resale value, your P is your MSRP, so your manufacturer suggested retail price. Your R is your annual depreciation rate, which is different depending on the vehicle, depending on the year, the make, the model. That has to be a decimal. And then N is your age of car in years. So how old the car is. Then we talked about the cost of owning a vehicle. So we talked about calculating fuel costs, which you have to do 2 parts to in terms of how much fuel is consumed, which is your total kilometers times your fuel consumption rate, and how much the fuel costs, which is your fuel consumed times your average cost. And then we also talked about calculating monthly average costs, which include fuel, maintenance, insurance, licensing fees, all those sorts of things. All right, we have a couple of quick minutes to do some last practice problems. Number 10, an SUV has an MSRP of $46,783 and it depreciates at a rate of 25% per year. Estimate the resale value after 5 years. So we're doing our V equals our price times 1, take away our depreciation rate to the exponent n. So our value is what we're looking for. Our suggested price is $46,783. Our rate of depreciation is 25%, so 0.25, and our number of years is 5. So how much it is after 5 years. So we just put these in our formula. Potentially after doing those RSP and loan formulas, this one doesn't seem quite so ugly. It's fairly straightforward. All right, stick it into our calculator. Oops, I put an extra 0 in. We don't want that. That's saying our depreciation rate would be 2.5%, which is not true. So that after 5 years, this SUV is worth $11,101.83. And that's how depreciation is calculated. Number 11, Josie drives about 25,000 kilometers per year. The fuel consumed rating for her vehicle is 6.2 liters per 100 kilometers. If the average fuel cost is $1.05 per liter, determine her average monthly fuel costs. So we're looking for, there's a bunch going on here. So first we need to figure out how much fuel she consumed. So we're gonna do that first. There is more than one way to do this question. It's okay if you do it slightly differently than me. That's fine. I'm going to do it this way. So how much fuel did she consume in the year? So you do our distance, 25,000 kilometers, times her fuel consumption rating for her vehicle, which is 6.2 liters per 100 kilometers. So we're going to calculate that. So 25,000 kilometers times 6.2 divided by 100, which is equal to 1,550. So that's how many liters of fuel she used in a year. So second step is to figure out the cost. So that's how much fuel. So 1,550 times $1.05 per liter. So we just multiply those two together and we get $1,627.50 is how much she spent on gas for the year, but we're looking for monthly. So we need to divide that by 12 because that's for the year. So divide that amount by 12 and that's $135.63 is how much she should budget per month in order to cover her costs for the whole year. So we don't have time to do this last question, but go back to lesson 10 if you need some more review. If you have any questions, please reach out and connect with me. You can give me a call to the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. Send me an email at broadwin.slate@nec.owen.ca or message at Facebook at bslatewasa. Remember, we have a playlist of all of our lessons up on YouTube. My channel is bslatewasa. The playlist is MBF3C. Everything is there. If you need to check out any previous lesson, go there and check it out. Thank you so much. Good luck with your review and Miigwech.